On this episode of Crash Course Chemistry, we will be talking about the elements gallium, thallium, and indium, and their unique characteristics.
Starting with gallium, it is a soft and silvery solid at room temperature. Its atomic number is 31 and its symbol is Ga. Gallium is the smallest of the three elements that we will be talking about. The existence of gallium was first predicted by Dmitry Mendeleev, a Russian chemist. He named it Eka-aluminum, being the placeholder right below aluminum in the periodic table. He predicted many of its properties, such as its density and its melting point. Gallium was then discovered by the French chemist Paul-Émile Lecoq using spectroscopy. He examined its spectral lines while looking through material separated from zinc blende. Soon afterwards, he isolated the metal and studied its properties. He determined the density of gallium to be 4.7 grams per milliliter. That was the only property that failed to match Mendeleev's predictions. Mendeleev actually wrote to Lecoq and suggested that he should remeasure the density. Lecoq then obtained the correct value of 5.9 grams per milliliters, which Mendeleev had predicted exactly. Gallium is not sitting in the earth pure, rather it's extracted from different ores and minerals. It does actually exist in some high content minerals. One of them's called gallite. However, these minerals are just too rare in occurrence to serve as a primary source. Gallium is usually mass-produced through the extraction and refining of bauxite and zinc deposits. When these minerals are refined to a pure form, gallium is usually obtained as a byproduct. Paul-Émile Lecoq named the element in French, Gallia, in honor of his native land in France, Gaul. Moving on to indium, its atomic number is 49 and its symbol is In. It's the second biggest in atomic mass of the three elements we are talking about. In 1863, two German chemists, Erroneous Richter and Ferdinand Reich, were testing ores from local mines. They dissolved pyrite, arsenopyrite, galena, and valerite in hydrochloric acid. After dissolving all these minerals, they filtered out any leftover zinc. The two chemists were actually looking for thallium with its noticeable green spectral bands. Reich was actually colorblind, so he hired Richter as a lab assistant, but also as a spectroscopy assistant to help him read the different bands. Instead of finding a green band, they found a bright blue one. Because it had not matched any other known element, they hypothesized a new one was in the minerals. They named the element indium from the indigo color seen in its spectrum, and also after the Latin word indicum, meaning of India. Indium is actually present in the Earth's crust. It's just about as rare as silver is. However, it doesn't form its own mineral deposits, so it's more economic to extract it as a trace constituent of other more common minerals. This is very similar to gallium's production. Most commonly from valerite and chalcopyrite, indium is extracted as a byproduct during smelting. Lastly, thallium. Thallium's atomic number is 81 and its symbol is Tl. It's the largest of the three elements we will be talking about. With the new method of flame spectroscopy, which is where scientists view an element's light patterns under its vapor form, scientists were rushing to find new elements. It was very promising as cesium and rubidium were discovered just 2 years before William Crookes and Claude Auguste Lamy discovered thallium. In flame spectroscopy, Crookes found thallium as a byproduct of selenium cyanide, while Lamy found thallium as a byproduct of sulfuric acid. Because Lamy was able to isolate a very large quantity of thallium, he was able to determine its properties, and he actually made a small ingot of metallic thallium himself. Most of the recognition went to Lamy at first for his larger contributions. even though crooks actually discovered thallium first. There was a controversy over who should receive more credit, but it seemed to end after 2 years. Now, both scientists are recognized as the main and equal contributors to the discovery of thallium. Thallium is actually modestly abundant in the Earth's crust, with a concentration of 0.7 milligrams per kilogram. It is mostly found in minerals, soils, clays, and granites, but it's not very economically recoverable from these sources. So, the major source of thallium is in the trace found in smelting copper, lead, and zinc. Thallium is named after the Greek word thalos, which means green twig, coming from its bright green spectral emission lines.
We will now be moving on to the elements' physical and chemical properties. Gallium, thallium, and indium are all very malleable, ductile, and shiny. And another specific physical property they have is that as you move down the group they are in, the melting point increases, yet the boiling point decreases. Lastly, they are all very reactive with oxygen and oxidize very easily. An interesting fact about gallium is that when it solidifies, it expands by 3.10%, which means it should not be stored in metals or glass, as it can break them. It also is one of the only metals that can melt when it touches human skin, which means it can be a liquid when you are holding it, but when you let it go, it will turn back into a solid. The main use of gallium is used in electric circuits and LEDs. Another thing that gallium is used for is in thermometers that can reach very high temperatures and barometers. The main use of indium is used in touch screens, flat screen TVs, and solar panels. It is also used to make mirrors that are as reflective as glass, but do not tarnish easily. Thallium sulfate is used as rodent and ant killer because of its tasteless and odorless, but was outlawed in the United States because of its toxicity to humans. Due to thallium being made up of mostly radioactive isotopes, thallium-201 is used to detect coronary artery disease. Thank you for watching this episode of Crash Course Chemistry.
We hope you learned a lot about thallium, indium, and gallium.
Bye.
Bye.